Okay, Foundation of Pre-Calc 10, let's get after it. We are moving into the wonderful world of polynomials. This is going to become more and more present in your math journey as you move forward. So let's kind of get a good start here, and it starts with vocabulary. So a term. What is a term? A term is a number, so 3. 3 is a term. Or the product of a number with one or more variables. So that means, 2 times x, that's a term. Or 2 times x, y, z, that's a term, because it's all multiplication. And then which can be raised to a power. So, 2 times x squared is a term. Or 3x squared y z cubed. Those are all terms, and they're all terms because they're separated only by multiplication. If you look at a statement like this, 3x squared plus 2, we have 2 terms, because here's one term and then here's the next term, because they're separated by addition. Or they can be separated by subtraction. Negative 4xyz minus 6x. Well, here is one term, here is the other term. Okay, so terms are numbers or numbers and letters with powers that are being multiplied together. That makes something one term. So what about what makes something a polynomial? Well, what makes something a polynomial is that a term or sum of terms. So let's look at a few here. Here's a term, okay? Here is a sum of 2 terms. And here is a sum of 3 terms. Minus 2x plus 4. Okay, there's a bunch of different statements. The variables appear only in the numerator, which means the variables are the exponents of the variables. Okay, the exponents of the numbers don't matter. The exponents of the variables are whole numbers, which means they are positive values that are not fractions, right? Here are the exponents of 1, here are the exponents of 2 and a 1, here the exponents are 1s, so we're all fine. Where you're not fine is if you have an exponent like this, 3x to the negative 2. That's not allowed, because if we remember our exponent laws, that actually becomes 3 over x to the 2, right? It goes down to the denominator. And that's why this says they appear only in the numerator. So easier, more straightforward, you need to have positive non-fraction exponents. If you have fraction exponents, because remember what was x to the 1/2? Well, that meant the square root of x, right? That's not a whole number, so that's not a polynomial. That's a negative number, so that's not a polynomial. So there's a little bit there of identification. Now, what about classifying polynomials? Well, this is just a vocabulary piece. A monomial, mono means one, it means a one-termed polynomial. So x or 5 or x, y, z, those are all one terms, okay? A binomial, think bicycle, is when we have 2 terms. And we're going to deal a lot with binomials. So things like x plus 2 or x squared minus 5. And I put them in brackets just to show you that they are their own thing. Polynomial, 2 terms. Trinomial, think a tricycle, 3 terms. So something that looks like this, x squared plus 5x minus 4. That is a trinomial. And again, I'll put it in brackets just to show that that is my polynomial. And then when you get to polynomial, poly just means many. So you could call all of these things polynomials, but we distinctly call one-term ones monomials, binomials, and trinomials. It's just a little bit easier, but you can call them all polynomials. So degree and descending order, this is going to come in handy. Now, the degree of a term, you'll see here, is the sum of the exponents of the variables in one term. So if you look at this here, I have x squared. So this is of degree 2. Here I have no variables, so that's degree 0. And here I have 1x to the power of 1, so that's degree 1. And customarily what we do is we like to put them in descending order. So highest to lowest. So I would rewrite this as 3x squared, and remember the sign in front of a number belongs to it, plus 2x minus 3. I'm now in descending order. The degree of the entire polynomial is the degree of the leading term, the highest term degree. So this would be a degree 2 polynomial. Here we have multiple variables, so we add the exponents together. 2 plus 3, so we have a degree of 5, and then here I have a degree of 4. So this one's already in descending order, and we say that it is a 5th degree polynomial because the leading degree is 5. Now here we have degree 4, degree 5, and degree 2. So in descending order, it's going to be negative 2x squared y z squared plus y to the 4th plus 3x squared. It's just good habit to put it in descending order. And again, this is a 5th degree polynomial. One thing to note, if you have, say, something that looks like this, x squared plus y squared plus xy, those are all degree 2. So if you have the same degree and you're putting them in descending order, it goes in alphabetical order. So in this case, x squared would come first, followed by xy, followed by y squared. So that's if all the degrees are the same. So degree in descending order. This is also covered in the grade 9 section of polynomials. You can always check the section 6 notes in the grade 9 section as well. Combining like terms. So just like we did in algebra, we're going to combine like terms here. But this time we're looking for the same variable to the same exponent. So here I have an x squared and here I have an x squared. Those are the same thing. So I can combine those. I have 4x squared minus 1x squared is 3x squared. Here I have a y term and a y term. Those are exactly the same variable to the exact same power. So I can combine them. I get plus 2y. So that is simplified. That's in descending order. And this is a 2nd degree polynomial. Now the next one, sure, I have fractions. So let's group these with what I have. Those are the same variable, same power, and those are the same variable, same power. So we'll go, okay, negative 1/2 y to the 5 minus 1/3 y to the 5 minus 4y cubed plus 5y cubed. This part's easy enough to combine. Negative 4 plus 5 is just going to give me 1y cubed. And this one's a bit of a pain just because I'm adding fractions. So I have negative 1/2 minus 1/3, which means common denominator. Multiply by 3, multiply by 2. So I have negative 3 over 6 minus 2 over 6, which gives me negative 5 over 6. So I have negative 5 over 6 y to the 5 plus y cubed. That is in descending order, and it is a 5th degree polynomial. So now what about evaluating a polynomial? So to evaluate a polynomial, much like function notation from section 3, we are substituting in x equals 4. So our function becomes f of 4. So we've done this before, except this time we have some powers in certain instances. So we would have this, we sub in 4 for x, and then we solve. And remember, we're bedmath, so exponents first, 3 times 16, which gives me 3 times 16, 48, minus 2 is 46. So for the next one, I'm subbing in x equals 2, so my function notation would become f of 2, and I'd get 5 to the 2 cubed plus 6, which is 5 times 8 plus 6, so 40 plus 6, so again, 46. Coincidence, 2 different functions, but we can evaluate for a polynomial at any given value of x. And remember, that is my input, and it kicks me out an output. And as you get into graphing, that'll make a whole lot more sense for you. Now, we are going to look at multiplying, monomials, binomials, and then trinomials. But then the latter few sections of 5 are all about factoring. But to understand factoring, you need to understand first multiplication. So these first examples we've done before. I have one term here and I have one term here. And I'm multiplying everything together, so it's my exponent laws again. It's numbers with numbers, so negative 3 times negative 2. And then a squared times b cubed times b to the 5. You don't have to do this if you can just go, okay, that times that, it's fine. But I'm just showing you in detail. So this gives me 6, a to the 4, b to the 8. It's important to consider that is what we call a product, and individually those are all factors. And you're going to see why that's important in the next video on factoring. So now in this next one, let's multiply all the numbers together. Negative 3 times 2 times 4 is negative 24. And now let's find all my y's. So I got y to the 2, y, and y cubed. So I'm multiplying a common base, so I add the exponents. So I have y to the power of 6. And then I have z cubed, z squared, which gives me z to the power of 7. So it's just exponent laws when you're doing monomials by monomials. Now you might have a monomial times a binomial or a trinomial, but you've seen this before too. This is water bombing. This is going to multiply in here and in here. Except now we combine water bombing with exponent laws. So 2 times 3 is 6. X squared times x squared is x to the 4. Add the exponents. 2 times negative 4 is negative 8. And then I can't multiply the x and the y and do anything with it, so it just stays as x squared times y. So we are water bombing in the outside value. So now water bomb in, water bomb in. So now I get negative 3, and again, put it in alphabetical order, x to the 4y, it's just, it'll help you later. And then plus, well, sorry, not plus, minus, because I'm multiplying in a negative 3, negative 6, y to the power of 4. Check your degree. This is degree 5, this is degree 4, so we're in descending order, and we're good to go. So that's multiplying. Multiplying monomials with binomials is water bombing with exponent laws. So that ties into video 5.1, and we're going to go from there with some multiplication of binomials, and then some really, really pertinent and enjoyable 3 full videos of how to factor quadratics, which are degree 2 polynomials. All right, keep going. I know this is a lot, but you're doing great.